And welcome everybody to the Daily Space Weather. I'm your host Dan, aka smAsho, and today we've got some interesting stuff to talk about. We're going to blast through a whole bunch of data. We'll be talking about how heliophysics is cosmology stories, strong meteorological storms in the south. First thing we'll look at is the closest star, sunspot 2810 up here. No other sunspot regions are currently active. We're looking at three wavelengths in the UV spectrum, 335, 193, and 94 angstroms on this composite image. Here's just 94 angstroms. There's that composite. Those are all iron UV emission spectral states, by the way. Now we've got some more extremely fantastic close-up images for you momentarily. First, a diagram of the solar system. So you can see Venus is swinging around to the backside of the sun right now. There's where things will be in 1 week. We'll have a gibbous waxing. Here's a star chart. I like to face mine to the south and draw in the ecliptic. And I like to use in-the-sky.org. Just put in your own zip code if you want to check that out yourself. And if you're up before dawn, you may see some planets rising. Let's bring up the sidebar to show you the animation of that. So you may see some planets rise ahead of the sun here. Mercury, Jupiter, and Saturn all slated to rise in front of the sun if you've got a clear eastern horizon. The radial flux has popped up as we forecasted. It's currently at 79 solar flux units. And the 10.7 centimeter radial flux for you new viewers is the most proportional aspect of solar output to sunspot number. So here it is in context. Here's a 1-year graph. You can see the black line up here. That's the radial flux of the 10.7 centimeter variety. 2,800 megahertz is the frequency of that radio emission from the upper chromosphere and lower corona. The red line down here is the sunspot number. And we've got some geomagnetic unrest conditions here forecasted by NOAA in 2 days, a little over 2.5 days, we'll say. You can see that forecast there of geomagnetic unrest late on the 19th. So that's the arrival of the coronal hole wind stream, and I wouldn't be surprised either to see it arrive early. Here are 2 more graphs, sunspot number and the radial flux. You can see how proportional those indeed are. So here's another full disk image, and we do see some plasma in between the sun and earth now. Large coronal hole here in the south, which is so significant that you can even see it in the 304 angstroms ionized helium view. And some massive filaments up there to the north of sunspot 2810, right around here where my pointer is. Here's a full disk 193 angstroms view, which shows you a great definition of that coronal hole. And you can see it's actually connected to the south solar polar coronal hole region, and it is south pole oriented. Here's a close-up of that. Again, we can expect to see some protons in about 2 days. As the solar wind is primarily comprised of hydrogen nuclei. Here's a close-up of sunspot 2810. And you can see it's been quite stable here over the past 24. And next, I would like to remind our viewers to not pole vault the caldera. Now, we've got all kinds of public service messages that we regularly put out here, and our latest one is, by the way, it's available in merch as well. Do not pole vault the caldera, as there are a lot of dumb people, and you got to tell dumb people smart things like don't pole vault the caldera. So please don't pole vault the caldera. And in our daily videos, we talk about calderae. So I think I have some leeway to produce the merch. Which calderae are exploding, you might ask? Well, Etna has produced its 14th paroxysm. So we see a periodicity emerging from Etna's activity. as it continues to erupt. Sakurajima also erupting. 8,000-foot ash plume above it on the Isle of Kyushu. Dakono also exploding. Flight level 070. It's producing a 7,000-foot plume of volcanic ash. Popocatépetl down in Mexico also exploding. 20,000-foot ash plume there. Pacaya and Fuego, the two Guatemalan volcanoes, are both exploding. 12,000 and 15,000-foot ash plumes respectively there at Pacaya and Fuego. Sangay in Ecuador, as well as Revenador, are both on the list. Sangay is exploding, producing a 22,000-foot ash plume, and we don't see volcanic ash in the satellite imagery of Revenador. And intermittent emissions at Sabancaya are a reminder to not pole vault Revenador or Sabancaya. Please don't pole vault any volcanic calderae. By the way, if you'd like to pick up a piece of merch with it, how about the active t-shirt? It's 100% polyester, which means it'll hold up great, as well as wick moisture for your athletic endeavors. And you can link to all of that at smAshomash.com. That is the smAsho merch shop, which will link you to this page. Check it out. It's got some extremely high-quality designs. If you haven't done so yet, you can link to all of that once again at smAshomash.com. And let's move into the realm of seismicity. The largest earthquake of the past 24 was a 6.6, downgraded from a 6.9 by the U.S. Geologic Survey. And it occurred off the coast of Kamchatka, between Kamchatka and the last Aleutian Island in the Aleutian Island chain in the northern Pacific Ocean, close to the Bering Sea. No tsunami warnings, watches, or advisories issued from that, and it happened at about 1838 Universal Time. We also saw an extremely shallow quake here, this one at 2,500 meters above sea level. Not so deep, directly under the main Mauna Loa caldera system. So that earthquake there, only a 2.5 magnitude, but occurring at over a mile high. An extremely shallow quake. Again, at a depth of negative 2,500 meters, 2,500 meters above sea level. So no major quakes besides that 6.6 at Kamchatka, as well as associated aftershocks. The area north of New Zealand looks like it's calming down as well. One deep quake here on the list so far, nearly 600 kilometers deep. This 4.8 magnitude quake at the Fiji region. A small deep quake in the Caribbean, once again, a 3.4 magnitude at Dominica. Happened early this morning, Universal Time at 1:29. Another deep quake near Fiji, a 4.4 magnitude at 583 kilometers depth. And let's continue on. There's lots of data. No major solar flares over the past 24, but we did see a B-class flare, which happened at 8:30. So at 8:30 last night, Universal Time, we did see a B-class flare. That was the peak moment of solar flux. And when we say solar flares, we're talking about photons in the form of X-rays. No proton strikes have been striking as far as the GOES 16 makes its measurements. No surprise there. We would have let you know if there was a coronal mass ejection headed our way. The GOES magnetometer, there it is over the past 3 days. We're seeing pretty high highs and high lows over the past 24 out of the GOES 16 magnetometers. And here's a visualization of the heliospheric current sheet. And we can expect to see some lower readings out of the GOES magnetometer, because not only is there a coronal hole wind stream on the way, but there is plasma bunched up in the corona. So you can see right here, this area of bunched up potential field surface source lines. That is a bunch of plasma suspended by the sun's magnetic fields, increasing the probability of coronal mass ejections by a little bit. No major risk at this point Here's a line of sight coronal hole plot, and you can see that large South Pole oriented red area there. Right here, that is the coronal hole, and we can expect to see a coronal hole wind stream from that in a couple of days. Again, geomagnetic unrest forecasted for the 19th, late in the day universal time. So here is a quick little diagram. Detected sunspot groups, and we are down to one sunspot group. It's just one sunspot, really. There are two separate umbrae there. They're both the same polarity last I checked. Sunspot 2810, an alpha class sunspot. Next, looking at the real-time solar wind. I would note that we did see a signal in the solar wind data here at the time that 6.6 magnitude quake happened. So right here you can see it's 1838 was the timing of that quake, and it happened at the same time that we saw a shift in the BTBZ as well as the phi angle. What we didn't see is a phi angle around 180 degrees. So you can see the solar wind density dipped a little bit here. The phi angle shifted from around 290 degrees to around 118 degrees, right around that moment. And we saw a shift in the BTBZ. The BZ actually shifted into positive territory and a small increase in the total field there. So that was really a North Pole-oriented solar geomagnetic jerk that happened there. And please leave us a comment with your favorite geomagnetic jerk. Let's go to the current conditions, which are a solar wind density of around just under 6 protons per cubic centimeter. Current solar wind speed, 351 kilometers per second. The KP index currently at 1. And we can expect to see this up to a 4 late night on the 19th. And I would say probably followed by a geomagnetic storm there, as that is a significant coronal hole. There is a bunch of electron bridging in effect right now in the solar system, and without getting further into that, because there's too much stuff to cover, let's take a look at the geospace magnetosphere movie for the day. Here's 4 hours of data. Magnetohydrodynamic pressure. And everything's pretty calm here. We haven't seen any major shifts in the solar wind velocity or density, or really in the BTBZ. And so we can expect to see this pretty smooth here over the past 4 hours, and indeed it is. I'm going to put this back to where it was since it annoyingly refreshed. Pretty uneventful there over the past 4 hours. Here are ground magnetic perturbations. We're looking at geospace delta B, otherwise known as changes to the Earth's B field. This scale is in nanotesla. So is the last one, by the way. And you can see some minor perturbations over places like central Greenland, as well as over the Antarctic continent south of Australia. By the way, we did stream this live thanks to our Twitch viewers, twitch.tv/smAsho. Twitch has a great mobile app as well. Perhaps consider that. We don't do all of our live streaming on Twitch, but it is a fantastic live streaming platform. We also do live streams on YouTube. If you're watching there, please press like and subscribe, as our subscriber count has stagnated between exactly 1,740 and 1,750 subscribers over the past solid 2 weeks. How that can be, I don't know. It doesn't sound organic to me. It sounds like it's algorithmic. But in any case, we're also on BitChute. There is exclusive content there as well. And if you're viewing on BitChute, make sure you view on YouTube as well, because we have most of our content on YouTube. So if you want to miss out on about, I'd say 60% of our content, don't watch on YouTube. Thanks to our BitChute subscribers. We're approaching 400 subscribers over there on BitChute, and we receive about 4 times as many views on BitChute as we do on YouTube. Thanks for leaving comments. Galactic Nova Space. Please watch the videos on YouTube as well, because Galactic Nova Space says, watched your vids on BitChute. Please watch them on YouTube, as there are playlists and all kinds of other features over there on YouTube that you will not see on BitChute. And let's do a cosmology segment, as it's full of interesting stories today. Today's cosmology segment, starting out with a random object, I picked a quantum random object today before I streamed live. It was number 962, which coincides with this object right here, known as HD200391, which is a very interesting binary system. It is also known as ER-Vol. So this is a interesting type of star, and I'll talk about that momentarily. Here it is in infrared light. That is the 2 mass you're looking at there. And what's interesting about this is it is a binary system where the binaries actually touch each other. At least their outer plasma spheres touch each other. Here it is on the XMM Newton. And here it is in blue light. And you can see it's a little bit of an oblong looking, you can see sort of 2 lens flare type circles here. And that's because it is a binary system. So this is sort of what's happening in that system. It's not your average everyday eclipsing binary. It is a special kind of binary known as a W Ursae Majoris variable. So these aren't your average everyday eclipsing binaries, as every time they get close to each other, they actually exchange material, where plasma gets funneled through their respective Lagrangian point 1, and they interact in some interesting ways. So this is part of the reason why this system is so bright. It's a very close non-eclipsing binary, actually. And you can read about these W Ursae Majoris variables on Wikipedia if you like. There's a whole list of them there. And I don't think they even list the one that we're showing here, so it's obviously an incomplete list. But that's something like what's going on with this particular one. And it doesn't show up on the Chandra. But there it is on the XMM Newton, the multi-mirror X-ray project. And again, that is number 962 on the Neil Gorell Swift-Bat X-ray Observatory, ER-Vol. Next, a fantastic imagery here of some Juno mission data showing the morning storms on Jupiter. Now, Jupiter's magnetosphere is created as a result of ionized particles, which come out of Jupiter's volcanic moon Io, and then they get ionized in Jupiter's magnetosphere. And in the morning, we see a situation like this happening at the poles. Juno's been the only mission to really get good imagery of this. The Jovian aurorae, the morning aurorae of Jupiter, yes. So some fantastic imagery of that. Jupiter has a very powerful magnetosphere. In fact, Jupiter's magnetosphere is so powerful that if you could see it with the naked eye, it would be about the size of the full moon. So just to give you an idea of how large Jupiter's magnetosphere is, if visible to the naked eye, it would be about the size of the full moon from planet Earth. So this is a phys.org article with some fantastic imagery here from Juno of Jupiter's aurorae. Also, another interesting story here about the Parker Solar Probe, and our regular viewers would be well aware of these little feedbacks here. You see this little switchback, it's called, where the solar wind just sort of reverses and then returns to its regular flow. Well, there are 2 new theories about this, and I don't know, you may think they're new, you may think they're not new. I'm not sure how excited you'll be about the story, but in any case, they are talking about magnetic switchbacks. Are they caused by a magnetic flux rope, or are they caused by magnetic reconnection, or perhaps they're just caused by interaction between the slow and fast solar winds? The real answer is we don't know, but there's a SciTech Daily article about it. You'll probably find it all over the Science Wire. Some folks attempting to explain the switchbacks, the zigzagging of the solar wind as detected by the Parker Solar Probe, which, by the way, is also the fastest object ever created by mankind that we know of, and the closest object that we've ever sent to a star. So the Parker Solar Probe is interesting. in that it has gone faster and closer to the local yellow dwarf than any other object ever has. And there is one of the diagrams of the possibilities of what causes, what's the physics behind the switchbacks. I'll just let the rest of the article scroll here so that you can view it without even clicking on SciTech Daily. You can just watch our video. And here's a great animation also of the Parker Solar Probe passing through one of those switchbacks, where the solar wind is going in different directions over a brief period of time. Do you have a theory as to what causes this? Well, leave us a comment and let us know, as we consider our YouTube channel to be a collaborative effort. And that's today's cosmology segment. I think it was pretty vast. I think it was pretty full of information. So make sure you press like and subscribe if you're viewing on YouTube. Leave us a comment if you view on BitChute. And don't forget to share the videos with your friends, your foes, your science noobs, and your science pros. Let's move on. To talk electrons, here's the one-year chart of the electron flux. As reported by Solon.info, and as forecasted by our channel, we see higher levels of electron flux here following that previous coronal hole wind stream, as space plasmas move like train cars. And without any further ado about that, here's a 3-day chart of the electron flux, and we've remained in electron warning levels here over the past 2+ days. And that red dotted line there coincides with 1,000 pulse flux units. This is actually showing you the density as measured by the GO-16 at the F ionosphere layer. So here is the forecast, and we're expecting a small downtick here and then a larger downtick around when the coronal hole wind stream arrives. I would tend to agree with that. No arguments with that forecast model. Here's a visualization of the total electron content. This shows you the whole air column up to the thermosphere where your GPS satellite is likely to be located. It's about a 12,500-mile column of air we're looking at here, and the electron flux is not looking particularly anomalous. Here's a diagram of the atmosphere which shows you where the F ionosphere layer is, about 300 kilometers. And next we're going to show you a slice, basically this slice right here. It's the vibrational frequencies of the ionosphere. You're looking at megahertz here. And sadly, the resolution is only 1 megahertz, not really enough to show you that much information, although it would show you any major anomalies. And I don't know if we have missing data here or what the deal is, but for some reason it's looking very glitchy and jerky. It looks like a straight-up geomagnetic jerk. And leave us a comment and let us know who is your favorite geomagnetic jerk. I've got a list of a few, which I will not mention in this video. Perhaps we'll mention those geomagnetic jerks in a Smash Holes of the Week segment. And we're getting very behind on our list of videos that we're about to make. In any case, there's the ionosphere. Here's the latest image, which comes through at 9 o'clock Universal Time. Next, looking at some meteorological data, it's the jet stream, as shown on nullschool.net. And I'm just checking the life of the stream here. Again, we did stream live. There are the jet streams of the Western world. And we see some extreme meridional jet stream bends here in the North Atlantic. We'll probably see stories coming out in about a day or two about how, oh noes, warm air is being injected into Greenland. And it's going to melt and sea level is going to rise suddenly and everybody's going to be very scared and spooked. We've got doubled up jet streams over the U.S. and an area of stagnation here over the Central Rockies, Central Eastern Rockies. Here are the jet streams of the Eastern world. And we still see western jet streams blowing east to west over the western Pacific, less so over the Indian Ocean. Next, looking at pressure cells here. This is windy.com's pressure map, and we're going to advance this into tomorrow's GFS forecast. That would be the GFS forecast for tomorrow at noon Eastern Time. And we see a powerful low here just south of the Great Lakes. at least powerful in terms of the surrounding high pressure gradient. And pressure gradients are what really cause violent weather, folks. And speaking of violent weather, we've got some significant terrestrial lightning. Here's the global real-time lightning map on blitzortung.org. And by the way, blitzortung.org is responsible for lightningmaps.org. Sadly, lightningmaps.org's Strasbourg servers burned a few days ago, and they're working at getting that situation resolved. And we see some lightning south of Memphis. So there's the heaviest lightning you can see around the Arkansas-Mississippi border there, as well as some strong lightning there in eastern Kansas and northeastern Oklahoma. Here's a cloud map. It's too early to see the clouds because it's still dark out, but we use the shortwave radiation map. 3.9 nanometers is the wavelength of this. Here's the water vapor map, and I would note some sudden cloud nucleation happening here in southwestern Texas. And just bear with me a minute. I want to make sure my bandwidth is good as I'm hearing some weird noises coming out of the smAsho bunker. Here's a water vapor map, and there's the cloud layer. Once again, you can see those suddenly nucleating clouds there over central Texas where they've moved now, as well as some sudden cloud formations happening there in places like Texas Stovepipe and Oklahoma. And that's certainly some evaporative processes there in central Texas. It looks like some hot air. And I hope that gives all of you folks seeing storms a little better insight. Here's the U.S. Doppler radar map, and you can see those heavy storms moving northeast, about to hit Missouri, Iowa, Illinois, eventually Wisconsin, and then the Lake Michigan region. And some strong storms moving across central Texas as well. Thanks to our patrons, the true source of funding for the content. Please consider helping us to continue to exist by becoming a patron at patreon.com/smashamash. YouTube does just this side of nothing to help us exist for obvious reasons. Patreon.com/smashamash. So here's what Sunspot 2810 looked like while we did show prep. There's the umbre. It's actually a sort of a single umbra that's split. And that is only one polarity there. As you can see, it's just a North Pole oriented sunspot, making it an alpha class sunspot. Here's a close-up of that area in 304 angstroms, a great view of that filamentary region. Just fantastic view of that filament, which is still largely suspended in the corona. Here's the same area in 171 angstroms. My personal favorite wavelength, and one of the crowd favorites as well. And we've got some more even closer up images of this. Oh, I got to show you the most current magnetogram and the most current intensitygram. So there's what I saw during show prep, and here's what I'm seeing now. We see a degradation of Sunspot 2810, and that certainly shrunk in the last half hour or so. Here's an extreme close-up of Sunspot 2810 and 94 angstroms. One of the many ionized spectral states of iron. 94 angstroms, the UV emissions of ionized iron. Here's 131 angstroms. Another one of the crowd favorites. Great view of that incoming active region and indeed sunspot. And last but not least, 171 angstroms. Great view of those filaments as well. It's about time to close this thing out. Thanks again for tuning in, folks. Remember, stare at the sun. Attempt to understand the physics. Don't drink, but if you do, don't drive. And since it'll never be now again, Welcome to the Neo-Renaissance, and may that solar wind be at your back. This has been a presentation of the Smash News Network, Least Busted, Name in News.